Next, I will introduce our instrument to you. So let's start with this. Here is one of our indicator lights, and then a reset, emergency stop button. This is our operation screen, and here is our printer, and this is our power switch. This is an excitation transformer we matched. This is our reactor, and this is our signal acquisition, a voltage divider, and a compensation capacitor. And let me show you the wiring of our equipment. Here is an input of our variable frequency power supply. Connects to a 380 volt power supply. And here, output. And then connected to the input of the excitation transformer. Then the excitation transformer can be changed according to our different wiring methods. To change our wiring, then select our experimental gear. After selecting, finally, our tap. The high voltage tap is connected to the low voltage end of our reactor. Then our reactor. Use it in series and parallel according to the conditions of our different experiments. Then we can connect the wires. Now we are in a 4-section series connection. Then the high voltage end of the reactor is connected to a voltage divider. A voltage divider. Then we can connect a compensation capacitor here. There is a signal line at the bottom of the divider, and then connect it back to the signal terminal of the frequency converter. This is one of ours. Our incentives have changed, and our voltage divider and compensation capacitors must be reliably grounded. Next, we will explain the use of our equipment. Here is a file management. Here you can view our historical data. Then you can open it for printing. Then there is parameter configuration, and then set our experimental parameters. Set it according to the ratio of the voltage divider, then the initial voltage. The initial voltage can be set slightly lower at first. Then there are voltages for each time stage. And here is overvoltage protection, overcurrent protection, which are all to protect our variable frequency source. Then we can set the withstand voltage time here. Set the starting and ending frequencies here. Then calculate the parameters. Then we can calculate the inductance of our linear actuator, and the voltage divider or compensation capacitor, and the approximate capacitance of the test object. To calculate the approximate frequency. At what stage? Let's talk about our manual experiment. First, we set our parameters. Because our compensation capacitor is 70 kV, we can only set it to 70 kV. Now click on the manual experiment. Start the experiment. After clicking Start Experiment, tune it first. Then the device will automatically find the resonance. After our frequency reaches the termination frequency, and then find our resonance point, then the device will perform a secondary tuning and find a more accurate frequency. After the frequency stabilizes, then our high voltage will go up. Then we can manually increase the voltage now to the specified voltage required for our experiment. We can adjust the boost gear here. It was 5000 volts just now, and now it can be adjusted to 2000 volts. After reaching the specified voltage, click to start timing for voltage resistance. After the withstand voltage time is reached, we can lower blood pressure. OK. After voltage reduction, we can save one of our trial data. It can also be printed. Here is the experimental data we just had. The test is completed. Here's another one of our automated experiments. The automatic experiment and our operation are also the same as manual operation. After clicking Start Experiment, and then he can do auto harmonic boost. Here, I just do a demonstration, and it won't increase the pressure. OK, the experiment is done.